Many products are very different in different parts of the world. TVs have tuners operating in completely different technologies in different regions. Appliances like tumble dryers or dishwashers use different designs between the US and the EU, sometimes radically so. Even eggs have completely different distribution procedures. But computers are pretty much identical everywhere, with the exception of the power cord. And yeah, the keyboard. The first device to feature anything resembling the modern computer keyboard was, of course, the typewriter. The idea of a typewriter's mechanism doesn't really call for any specific ordering of the letters, and the earliest models featured an alphabetical layout, as evidenced in this US patent from 1868. For the subsequent models, the keys were rearranged numerous times. It clearly descended from the alphabetical order, as evident by the large alphabetical clusters in this 1870 layout, but the changes were supposed to make typing faster and more comfortable. Letters were swapped around so that the most commonly used ones were in the middle, and common letter sequences to be typed easily by alternating between the hands. Since the earliest application of the typewriter was to quickly write down telegraphs being received, even the Morse code was an influence. By 1882, the modern QWERTY layout was essentially perfected, although you can clearly see that some punctuation keys are laid out differently. While it feels random at first, it's not that hard to see that it descended from an alphabetical layout. The layout continued with minor evolutions over the years. For example, electric typewriters adjusted font striking force per key, but due to cost, it did not account for the state of the shift key. That required both of the keys' glyphs to have a similar density of ink printed, which called for rearrangement of some punctuation. Most notably, the double quote was moved from its common position on the number 2 to share a key with the apostrophe. Similarly, when computers started gaining popularity in the 1970s, one common design simplification called a bit-paired keyboard was to arrange the punctuation in such a way that the shift key could be implemented by simple bit flips in the character's ASCII codes, while mimicking either of the common typewriter layouts would require fully separate mapping for it. Meanwhile, in non-English speaking countries, American or British typewriters were imported and adapted to local languages. Where the Latin script is used, the general layout was usually retained, but some lesser used punctuation were substituted for local diacritics, and sometimes some other keys were swapped. For example, German typewriters swapped Y and Z to allow typing TZ, a common sequence in German, more easily, creating the QWERTZ layout. It was then in turn exported to some other neighboring countries like Poland, who switched to QWERTY in the computer era though. For some other languages, particularly those using other alphabets, original layouts were often created, like the Russian Yitsukien layout. Most of those national layouts from the typewriter era were carried over into the computer era in some form, but the history of keyboard layouts for each country and language is unique and often obscure. If you look at the list of keyboard layouts available in Windows, macOS or any modern Linux distro, you'll find literally hundreds of entries. But we can organize them to make a little bit more sense of all that. If you remove all the key labels, there are 5 regional variants of a keyboard's mechanical layout. The so-called ANSI layout is a national standard of the United States, and its final modern form came to be around the mid-1980s, with the gold standard being the iconic IBM Model M. The ANSI layout is easily recognizable by the single-row horizontal enter key and the backslash key above it. Some non-standard variants with an L-shaped enter key can also be found. There are a couple of places where the backslash key may be found instead. The ISO layout is popular in other regions such as Europe, although the name is a bit of a misnomer because the actual ISO standard it's based on makes provisions for varying layouts, and the ANSI layout would also be found conformant. Anyway, the canonical ISO layout changes the shape of the enter key to a vertical bar, replacing the backslash key above it with a key squeezed next to the one that is the apostrophe on the US layout. It also has an additional key between what's the letter Z on the American layout and the left shift key. It means that the ISO layout has one more key. Since the introduction of Windows 95, the standard key count on a full-size keyboard is 104 for ANSI and 105 for ISO. The ANSI and ISO layouts are by far the most popular, but there are also 3 unique national standards. The Japanese JIS layout has a vertical enter key like the ISO layout, but there is no additional key on the left. Instead, there are two more keys on the right, squeezed to the left side of the backspace and right shift keys. There are also additional keys for switching input modes and script conventions specific to the Japanese language. Those depend on the platform, but the most common PC layout has three of them around the spacebar. Also, uniquely, the key above tab housing the tilde on the US layout is a function key in Japan. This will be important later. Also, since we're talking about the Japanese keyboard, note that it retains the bit paired punctuation. South Korean keyboards, sometimes called the KS layout, although that again is a bit of a misnomer, are nearly identical to the ANSI layout, but often feature two additional dedicated keys for switching between input modes related to the Korean language. The big L-shaped enter key is also more popular in Korea. Last but not least, Brazil also has its unique national layout dubbed ABNT or ABNT2, which is much like ISO but squeezes yet another key to the left of the right shift key, like in the Japanese layout. It also defines a unique numeric keypad, so if a keyboard has one, it shall have an additional middle dot key above the keypad's enter key. All of these 5 regional mechanical layouts, of course, also have size variations like the 10 keyless and various compact sizes. On top of those mechanical layouts, there are then the visual layouts and functional layouts. The functional layout is what you have set in the operating system. The visual layout is the way the keys are labeled, and there are significantly less of those. Of course, you may find specialized boutique keyboards with niche layouts, and some users will modify theirs with custom keycaps or stickers. But if we're talking about mainstream brands like Lenovo or Apple, they produce about 30 to 40 variants of visual keyboard layouts. Some of them combine multiple functional layouts. For example, a Ukrainian keyboard may be labeled simultaneously for US English, Ukrainian and Russian. 3 functional layouts switchable in the operating system. About that, how do a keyboard communicate to the CPU what keys have been pressed? It does not send letter codes, except it kind of does, but we'll get to that. It sends a thing called scan codes, unique codes that encode the position of a key on the keyboard, regardless of what's printed on it. Various scan code standards were developed over the years. Some made quite a lot of sense following the order of the physical keys closely. Some looked completely random. Some almost made sense but deviated from an apparent pattern, probably reflecting some features of the original keyboard PCB design. Legacy PC keyboards were switchable between 3 different scan code sets because of reasons, which is also quite insane. And scan codes for the modern PC layout were designed to look like it emulates the original 83 and 84 key keyboards, unless the software is aware of the new keys. But the modern standard for keyboard scan codes is described in the USB Human Interface Device specification. Although invented for USB, it's also adopted for Bluetooth and even in internal proprietary interconnects used on some laptops, including those from Apple. The HID scan codes are interesting, in the sense that they follow the alphabetical pattern of keys as they show up on a US English QWERTY keyboard. So if you've got a QWERTY keyboard, it kind of does send the text that is being typed. But if your keyboard is, say, French AZERTY, the keyboard will act as if it's drunk. Those are just numbers, you might say, but that has real consequences. The computer on its own has no way of telling what is printed on the keys. It has no idea if the keyboard you're using is US English, French or Russian, even if it's built into a laptop. So imagine you're a French person living in France with a laptop produced for a French market. You want to install Linux on it. You boot your Ubuntu USB stick and it fails. You read up and find that the workaround is to add a no mode set argument in the bootloader. Except when you type it, it shows up as no ode set. That's because without an OS running, your computer assumes that it has a US English QWERTY keyboard, and on the French keyboard the M key is in a different spot. To get things working, you need to pretend you had US English keycaps on your keyboard until you finally get the OS running, where it will ask you about the keyboard layout as one of the first questions. Some UEFI firmwares will have the option to change the pre-boot layout, but most won't. If you set up a BIOS password, it will likely be handled as a sequence of layout-independent scan codes. Once you fully boot an OS, it will handle the layout mapping, but if you need to do some service maintenance, like in the Linux installation example, you may run into surprises. Is US English at least the default everywhere? Almost, but for example the default Raspberry Pi OS images made by a British company are notorious for defaulting to UK English, which differs in locations of some punctuation that will be important when setting up the OS. Some keys are also weird. On PS2 keyboards you could only tell when the pause break key was pressed, not when it was released. And you know that infamous Copilot key that Microsoft has been trying to force onto new laptops since 2024? It takes the place of more useful keys like menu or even right control and cannot be easily remapped to anything you'd actually want. And that's not just due to Windows knowing better what you need. It doesn't have a dedicated scan code. Instead, it's like a macro hotkey that emulates a Shift Windows F23 key combo. In hardware. Good luck remapping that. And it doesn't matter that F23 is nowhere to be found on its own. And then there's application software. Say you need to write a game. The WASD keys will probably be important to you, but on a French keyboard those will actually be ZQSD? Well, you can read the keyboard in a couple of ways in the OS. For example, on Windows, depending on the method you use, you might get either scan codes or so-called virtual key codes, which will correspond to ASCII letters. Except when the keyboard is non-Latin, for example, the virtual keys for the Russian layout will act if it's QWERTY. Why? Well, because some common keyboard shortcuts like Ctrl-C and Ctrl-V for copy and paste depend on that, among other reasons. And the Windows scan codes are not the modern HID ones either, but values derived from those used on the original IBM PC back in 1981. Why? Well, for one thing, most Windows laptop keyboards continue to act like it's 1981 internally. Also, Windows is old. Over the years it had to support multiple types of keyboards. Legacy PC, USB, even some oddballs like the Japanese PC-98 ones. So Microsoft made those be translated into a common set, and the Legacy PC one was adapted probably because it was the most common at the time those interfaces were designed. Similar thing happened on the Mac, where the scan codes delivered by the OS are still compatible with the original 1984 Macintosh keyboard. If that's not enough, another way of interacting with the keyboard is the OS's text input, which may not be mapped to keys directly. For example, East Asian languages like Chinese and Japanese will open up a thing called Input Method Editor that allows you to choose from those thousands of ideograms on a keyboard that only has a couple dozen keys. And even in more familiar languages, many layouts have dead keys. I'm referencing the French layout a lot in this rant, so let's stick with it, as it has an example of a dead key right here. It's labeled with the circumflex and the diaeresis, but it doesn't produce those on its own. Instead, when you follow this keystroke with an E, for example, it will produce an E with a typed accent. So, when you're designing a game, you probably need to make sure that in-game controls like WASD don't depend on the keyboard layout. If there's a chat feature, it should integrate with input method editors and dead keys, and if there's any kind of text editing like copy, paste or undo, that should take the keyboard layout into account to get the shortcuts right. And if that wasn't enough of a mess, there's also... The Apple Mac line of computers is essentially the last, which is still relevant today, that tracks back to times before the IBM PC and its clones achieved total domination. The Model M layout wasn't the de facto standard yet when the first Macs came out, and this continues today. Apple's keyboards are just a bit different. Just enough to make some additional mess. The first thing you'll probably notice when moving from a PC to a Mac are the modifier keys. A typical PC keyboard will, in its bottom left corner, have the Control key, the Windows key, also known as Super among Linux enthusiasts, and the Alt key. Laptop keyboards may also have the Function key, either in the corner or between the Control and Windows keys. Apple keyboards, on the other hand, will have the Function or Globe key, the Control key, here spelled in full, then the Option key, which sends the same scan code as the PC Alt key, and the Command key, which sends the same scan code as the PC Windows key. See what happened here? Now the keys are reversed, for no good reason other than Apple having this layout first. To be fair, Microsoft may be to blame here, as originally PCs didn't have the Windows key. It was introduced specifically for Windows 95 and they decided to put it in the middle. Maybe to mess with Apple, who knows. But it gets even more messy when you consider the function of those keys in those OSs, where the Windows and Linux have Ctrl-C, Ctrl-V, macOS has Command-C, Command-V. Where Windows has Ctrl-Alt shortcuts, macOS often has Command-Option shortcuts. So if you say have a MacBook, use it with an external keyboard when on a desk, and sometimes use Windows software on it, either through virtual machines or something like remote desktop, you're basically dealing with 4 different arrangements of the modifier key usages. Good luck with your muscle memory, although, to be fair, macOS allows remapping modifier keys separately for each of the connected keyboards. And it gets even weirder in Japan, but we'll get to that. If you happen to live in a place that uses international English keyboards, basically US QWERTY but with an ISO physical layout, you'll notice that on Macs the tilde key is moved to the left of the Z key, and the key to the left of 1 is this weird plus-minus paragraph thing. For whatever reason, Apple ISO keyboards have those 2 scan codes reversed since forever, dating back at least to the original Mac. Native ISO layouts like German take that into account, but in others like the International English, the tilde is just repositioned for no apparent reason. Speaking of English layouts, if you buy a Mac in the UK, you'll notice that it has an almost American layout, only with the pound sign replacing the hash symbol. PC UK layout has more significant differences, most notably the double quote and the @ sign are swapped, likely stemming from the story of switching from manual typewriters to electric typewriters to computers going differently. Apple apparently never got the memo. It's not just the UK. Apple's French layout is actually adapted from Belgian. Various layouts have punctuation rearranged. Croatian Slovenian is a QWERTY layout rather than QWERTZ like on the PC. Arabic has a lot of letters rearranged, and for Brazilian Portuguese there's only US QWERTY with some keys made dead, because there are no ABNT keyboards from Apple. Also, Apple has this nasty habit of not labeling symbols available through the Option key, equivalent to Alt-Graph on the PC. So good luck hunting where are the square brackets on the French layout. And no, they aren't in the same place as on a PC. And of course, if you go to a store and buy an external keyboard, most of them will be marked with a local PC layout. macOS supports many PC layouts, but if you alternate between using internal and external keyboard with a MacBook, you'll either need to switch layouts a lot, live with labels not matching the keys on one of the two, apply some stickers, or splash out on a product specifically designed for the Mac. And then there's the keyboard Apple ships in Japan. At first it looks normal, but then you realize. Remember when I said that what's the tilde key in the US is a function key in Japan? Yeah, on the Japanese Apple keyboard there's nothing there. The whole layout is shifted to the left to compensate. And the modifier keys are all over the place. The globe key is moved to the right side, replacing the right option key, and control and caps lock are swapped for some reason. The Japanese specific input mode keys are also different, but that's the least weird thing about this layout, especially since some new Windows laptops changed that too. And remember that function or globe key? On PC keyboards it's usually handled largely in hardware. The OS may not even be aware of its existence. The keyboard will send scan codes either for standard function keys or for the extra multimedia keys depending on its state, on its own. If its state is sent to the computer at all, there will be a proprietary extension interacting with some model-specific drivers. But that's only for improving the user experience, like showing this toolbar on some old Toshiba laptops. The keys will function on their own. Well, not on Macs. The function key row will always send standard function key scan codes. The globe key sends a custom extension to signal its status, and that's it. Everything else happens in software. Or doesn't, like if you try using an Apple keyboard on Windows without special drivers, or if you're using a PC keyboard with a Mac and miss out on some default keyboard shortcuts, because even if you have a function key, it won't work as Apple intended. And if you're wondering, Linux needs to have a specific driver just for Apple keyboards to handle all those quirks. That's not even everything. Places that aren't lucky enough to have their own keyboard layouts manufactured visually by major vendors are stuck with either arcane key mappings that are not labeled at best and contradict the labels at worst, making custom stickers popular. There is even more mess in software, like for example Polish version of Windows used to configure the obsolete quartz layout by default as either the primary or secondary layout, even though literally nobody used it, causing countless family tech support calls ending with press Ctrl-Shift. I think that I convinced you enough already, though, that keyboards are a mess. It's almost a miracle that we are able to type and use our computers around the world. Just appreciate all the engineers who somehow made it somewhat work, and all the poor people who ever had to use a public computer with an unfamiliar keyboard abroad.